Alright guys, I realized that I didn't get the second part of this chapter onto the week 1 module, so I need to go ahead and get that out there to you guys. I'm going to record this video, and if you guys have any questions at all about anything, just don't hesitate to text me through Remind or email me, and I will get back with you as soon as possible. So those first few videos should have gone over pretty well on the metric system and sort of conversions, and I think then we start about here. So I'm going to go ahead and play this, and this says that as far as understanding measurements, this is going to get us into the vocabulary word data, which is what we're going to have to, of course, take whenever we do our labs, ratios and generalizations. So this next bullet says density. Density is a ratio that that's basically what your homework, as far as the chapter 1 homework, not the reading assignment, but the other part is going to entail. It's going to have mostly density type equations. And then also, whenever we're doing measurements, it's really important to know what the symbols of those measurements are and like the different equations that have those symbols. For instance, when we do get into density, its equation is mass divided by volume. So the symbol for density is known as a rho, and the symbol for mass is m, and the symbol for volume is v. Okay? And of course, this is the equation for density. All right. And as far as quizzes and tests are concerned, I give you the equations. You don't have to memorize them, but you do need to know which ones to use. So you definitely need to know what those symbols mean. All right. So as far as data, like for instance, we'll do a lab where we have a cube and we'll have to find the volume of that cube. If you guys remember, volume of a cube is length times width times height. So for instance, if we were talking about 1 centimeter by 1 centimeter by 1 centimeter, then the volume would end up being 1 centimeter cubed. Okay? And obviously this is a measurement for volume, but you could do measurements for all kinds of different conditions or events. So if we were going to compare the ratios of two different things, so we've got area, which surface area is, of a cube anyway, is 6 times length times width. So if you had a cube that was 1 inch on each side, 1 by 1 by 1, something like that, then it would be, as far as length and width is concerned, you would do 6 times 1 times 1, which is this 6 inches squared. Because whenever you multiply by the length and the width of the inches, then those become squared. And then if you were doing the volume is length times width times height. And so that would be like 1 times 1 times 1, which is why you get 1 inches cubed. And then if you were going to do the ratio of those two, area and volume, then you would just do the 6 inches squared over the 1 inch cubed, and you end up with this 6 divided by 1, or 6. And then they go on and do it for if the cube had 2 inches or 3 inch sides. Okay? So that's a ratio. Now we get into density. So density, like I said, is mass divided by volume. So you should write that down somewhere in your notes. And you should know that density is it's a physical property, which means that if I went and I got a chunk of gold somewhere and I came back to my classroom and I measured the mass of it and I measured the volume of it, it should always equal around 19.3 grams per centimeter cubed. This is the density for gold. So when you go to do your homework, sometimes it will say I don't know, this is just like a random one, but it says like, what's the mass of this piece of gold that has a volume of 1 centimeter cubed or something? Well, so it's only giving you one number in the problem, but you have to go back through the textbook and look up the density for gold. So I want to kind of show you that really quick because I brought this up and I don't know if it'll open or not since I'm on Safari. I just thought about that. Yeah, these things don't particularly like Safari. When I say these things, I mean like Connect. I thought I had Firefox somewhere too. I know I do. There it is. Okay. So if you go to your Connect or McGraw-Hill, it should be like just attached to your Canvas. Well, I can't do this because then you guys will see my password. Great. Well, what I was going to do anyway was just show you what it would look like if you were to pull up your book. Hopefully you guys know how to do that, and I can do another video to show you that. But I can't type in my password. I see in it. So anyway, this is what the homepage of your Connect should look like. Let me go over here. Okay, so there is a table though in that textbook, and let me find it on my book. It's table 1.3. We'll have all of those density values. Okay? All right. So let's do a couple examples of density really quick. And these are also in your textbook, so if you wanted to go to the ebook, you should have access to that and go to example 1.1. It's in the text. You can go through this example with me really quick. So example 1.1 says that 2 blocks are on a table. Block A has a volume of 30 centimeters cubed and a mass of 81 grams. Block B has a volume of 50 centimeters cubed and a mass of 135 grams. Which block has the greater density? So let me draw this out in case you guys can't get to your book at the moment. You've got block A, which has a volume of 30 centimeters cubed and a mass, of 81 grams. And then block B has a volume of 50 centimeters cubed and a mass of 135 grams. So it wants you to find the density and figure out which one has the greater density. So if you were to plug into your density equation, you've got 81 grams divided by 30 centimeters cubed. So 81 divided by 30 is 2.7. Okay, so do the same thing for these values over here. So you have 135 grams divided by 50 centimeters cubed, which is 2.7. So you have the exact same number. Well, then if you were to go to that table 1.3, you would see that 2.7 is the density for aluminum. Okay, so you might have a homework problem that's sort of similar to that. This was example 1.1. Okay, I'm gonna erase this and do example 1.2 really quick, so you can always rewind on the video. All right, so example 1.2 says a rock with a volume of 4.5 centimeters cubed has a mass of 15 grams. What is the density? So density is mass divided by volume. So 15 grams divided by 4.5 centimeters cubed. So So just do your 15 divided by 4.5 and you get 3.33. You want to make sure that you have the right number of significant figures, which we haven't really quite gone over yet, but I will go over that here in a moment. All right, so as far as symbols and equations, we've kind of already gone over that. Symbols are kind of like that rho or M or V, depending on what you're talking about. The equation is going to be a mathematical representation between those properties. So density is mass divided by volume. That's how they're related. You can have things that are directly proportional. If they're directly proportional, then they have this funny symbol that looks kind of like a fish. If they're inversely proportional, then it still has this fish symbol, but it's like 1 over that. Okay, so the example that I give a lot when we get into forces, which we're not into forces yet, but if we were, I would say that, it won't let me. A is proportional to B. So there's an equation when we get into forces that looks like this. And it's force is equal to mass times acceleration. We can rearrange that equation where we're solving for acceleration, which is force divided by mass. Well, you see how acceleration and force are on like sort of the same level? Well, so that would be like acceleration is proportional to force. So the more let's say I'm riding a bicycle, the more I apply to those pedals on a bicycle, the more I'm going to get faster and accelerate. Those are proportional things. Whereas acceleration and mass are sort of on the different levels. So it's more like this equation where they're inversely proportional. So if I add mass to the bicycle, but I apply the same amount of force, then my acceleration is inversely proportional to mass, so 1 over that. Okay. For whatever reason, it's not letting me move on from this slide. It's annoying. Okay, so there is a little bit of a historical section to this chapter that tells you sort of like the nature of science, and you know how there were different scientists like Galileo and Newton who had different ways of thinking. Galileo was kind of like one that sort of thought that the earth was the center of everything, and then Newton, he also was like, hey, if you throw a ball, it should keep going. The only reason that it stops is because of friction or stuff like that. So these are scientists that had sort of these ideas of why things were happening. And some of our ancient philosophers just sort of thought about them, or then obviously when we get into more modern science, they actually did experimentation to prove that those things were in fact true. Okay, scientific method. Scientific method, you will need to know the steps to the scientific method as far as the order of them. I would not make you memorize this list. I would make you know which order they are in. So, for instance, the first step in the scientific method is just to observe something that's happening in nature. So I always use, like when my kids were babies, I use the example of them walking. So before they could walk, they obviously were observing us walking around, okay? And maybe somewhere in their mind, they thought, well, I guess if you get on your legs, then you can walk. And then, so they kind of, had to think about what we were doing. And then step 3, it says you use the explanation to make predictions. So if I just get on my legs and I move one in front of the other, then I'll walk. And then the 4th thing was to actually test that prediction. with an experiment. Well, so what did they do? They let go of the table and they started walking. But did they walk? Probably not. Not at first. They fell, probably. So if they fell, then they had to go back to step 3 and they had to figure out, well, what they were doing wrong and how to fix it. They give you a much more complicated example of the scientific method, and I don't like it, so I don't use it. General scientific activities, you are going to, in lab, you're going to have to collect observations or data, and you're going to have to explain why things happen the way they did, and then of course you're going to have to test those explanations with an experiment. And there is some more vocabulary on this slide, so you need to know like the definition of a hypothesis, which is, as we know from high school or whatever, it's like an educated guess. This is a little bit more intense. It says a tentative explanation for an observation. An experiment is a recreation of an event, and it needs to be based on the hypothesis. A controlled experiment, let's say for instance that I had, I don't know, some kind of pill that made you concentrate or something, I don't know. And I have 2 different groups. I have a controlled group and I have an experimental group. And each person, let's say I have 50 people in each group to make it even. And each person in each group gets a pill. The controlled group, they don't get the actual pill that is being experimented. They get a pill that looks like it, but it doesn't actually, it's not that same pill. Whereas the experimental group gets the pill. So what happens, or what tends to happen anyway, is that the control group, some of them might actually concentrate a little bit better. That's what's called a placebo effect, where they think they're getting it. And then the experimental group is getting the actual pill, and then hopefully it works. If it doesn't work, then they have to go back to square one. So, sort of the difference between these 2 groups. And scientific communication is important. You need to be able to not only say things, but you need to be able to write things down in science. And that kind of gets us into some ethics about science. Pseudoscience is misleading and often absurd claims of scientific results, writing answers down that aren't really what you got, or claiming that you found something that somebody else did. So, bad. Laws and principles. So, what I think I'm going to do actually is stop the video here, and then I'm going to start another video, and I will actually show you the textbook on this next video so that you guys actually know how to do that for sure.